Ever wanted to create an AI video where you have total control? I'm talking about deciding exactly who the character is, what outfit they're wearing, and the exact environment they're standing in. Well, I've got huge news. Today, we finally have a solution that lets you do exactly that with incredible quality, and the best part? It is completely free. Hello everyone. I'm Sotai. Welcome back to the channel. Like I mentioned at the start, the ultimate goal isn't just making an AI video that moves smoothly but is totally random. No, the goal is creating a video that matches your exact vision. The biggest problem right now? Whenever we try to force a specific character or setting into models like one video, they tend to just freak out. The current solutions are all over the place. Sometimes the character looks different, sometimes they get distorted, or worse, the composition just looks completely fake and unnatural. That is exactly why I'm introducing a solution today called BindWeave. Its real power lies in letting us place the exact character, in the exact outfit, into the exact background we want, with incredibly high consistency and natural logical positioning. In this video, we're going to do two things. First, I'll walk you through how to build the workflow. And second, we'll demo and stress test it to see if it actually keeps the character consistent like the rumors say. And of course, I've got a few pro tips to help you optimize this workflow for the best results. Alright, let's get right into it. First, let me quickly introduce BindWeave for those of you who haven't heard of it yet. BindWeave is a solution developed by a team of authors from ByteDance, the parent company of TikTok. This solution lets you control input subjects with an extremely high level of consistency, outperforming pretty much all current approaches, from open source projects to commercial tools. Just look at these results. BindWeave allows you to generate videos with literally any character you want. Whether it's a single person or multiple people in the same scene, their identity is preserved very clearly and consistently from start to finish. Not only that, you can also bring in other elements like animals, objects, or even the entire background, and BindWeave still maintains strong control over identity and delivers physically plausible human-object interactions. Alright, so that's a quick intro to BindWeave. And the good news is, the authors are actually giving us the model for free. So now, let me walk you through how to build a BindWeave workflow inside ComfyUI. Of course, there are a few things you'll need to set up first. The first one is a custom node. Luckily, BindWeave has already been integrated by ComfyUI into the Video Wrapper node, so you just need to install this popular custom node. However, BindWeave is not on the main branch. So after installing the Video Wrapper node, you need to go into the Video Wrapper folder inside your custom nodes. Run the command git switch BindWeave, then restart ComfyUI. After that, you'll see the corresponding node show up. On top of that, you'll obviously need to download the required models. The BindWeave model itself has been uploaded by ComfyUI here in Float 8 format. You'll also need to download additional models like the Light X2V LoRa, Clip Vision UMT5, and a VAE. There's also one more model, Quen 2.5 VL, because BindWeave was trained together with features from this model. I'll leave all the download links for these models in the corresponding Patreon post. Alright, once we've got the whole environment and all the resources set up, we can finally start building the BindWeave workflow. Before jumping straight into the main workflow, let me quickly walk you through the core idea behind it so you can follow along more easily. As you can see, we've got a new node here called OneVideo Add BindWeave Embeds. This is basically the heart of the entire workflow. This node takes a few inputs and then generates image embeds, which are passed into the OneVideo Sampler node. That's the part representing the actual model sampling process. The other inputs and outputs of the sampler node should already look very familiar if you've watched my previous videos. So the main job we need to focus on is preparing the proper inputs for the BindWeave Embeds node so the whole workflow can run correctly. To make this clearer, I've also pulled up the BindWeave architecture diagram from the author's paper. First, we have embeds. This corresponds to this region in the diagram. These are the embedding values of the input images after they've been processed by Clip Vision and the VAE. Second, we have reference latents. This represents this area in the video pipeline, where we initialize latents from the input images. Third is the reference mask. As you can see, this one is optional. The reference mask defines the region around your target subject so the model can focus on extracting information more accurately, instead of being distracted by irrelevant areas in the input image. And finally, we have QuenVL embeds. These are the outputs from Qwen 2.5 VL after it takes both the image and the prompt as input. So now that you understand the inputs and outputs of the BindWeave embeds node, let's move on to the main workflow, where I'll show you exactly how to construct all these inputs based on the original diagram from the authors. Alright, so this is our main workflow. I've broken it down into 3 stages. In the first stage, we'll prepare all the input data and configure the key parameters. I'll start by uploading the character image here. Then I need to resize this image to match the video resolution I want. In this example, I'm using a height of 528 and a width of 960. You can tweak these values depending on your own hardware and performance. After resizing, I'll store the result in a variable called resized image so we can reuse it in the later stages. You can see the resized and padded image preview here. For the padding, I'm filling the missing areas with pure white using the value 255 so that the input format is consistent with what the original authors used. And like I mentioned earlier, if you want the best possible video quality, you should really use a mask to define the subject region. Just to keep things simple in this demo, I'm using a mask that covers the entire subject including the background. If you don't want to regenerate the original background, you should use a mask that removes the background area. Just like with the image, I'll store the mask into a variable called mask for later stages. I'll also store width, height, and number frames. Here number frames is set to 128, which corresponds to a bit over 5 seconds of video. If your GPU can't handle that, you can absolutely lower this number. And finally, we have the prompt that will guide the video generation. I'll keep it simple. A woman making a heart gesture with her hands. Now let's move on to stage 2, where we'll generate all the core inputs for our main components, the BindWeave node and the OneVideoSampler node. First, we load the VAE model, and I'll store it so we can reuse it later for encoding video latents and in other components. Next to that is the OneVideo model, where I'll load the BindWeave model, as you can see here, together with the LightX2V LoRa to reduce the number of denoising steps. This combined model is stored in a variable called model and then plugged into the OneVideoSampler node. Next, we prepare the inputs for the BindWeave node. Like I explained earlier, embeds represent the region here in the diagram. So we use the clip vision model to encode the input image. Then its output is passed into the image-to-video encode node together with the VAE model, and that finally gives us the embeds value here. Then we have the reference latents. This part is simpler. We load the input image again and encode it using the VAE model. Reference mask is just the mask value that we saved back in stage 1. And finally, we have the Qwen embeds. I'll feed the input image together with the prompt into the QuenVL model and store its output. Note that here I'll resize the image again specifically to optimize VRAM usage. And to match the original design, I'll also encode the prompt using the UMT5 model, as shown in the diagram, and store that as well. The final stage is the sampling process in the main workflow. As you can see, once we have all these values ready, it's just a matter of plugging them into the right inputs. The output from the OneVideoSampler node is then decoded by the VAE model and saved by the Video Combine node with an FPS of 24. And that's it, we've completed the BindWeave workflow. Not that complicated once you break it down, right? Now just hit run and let's see what kind of results you get. And here we go, this is the result. Yeah, that looks awesome, right? The workflow nailed exactly what we asked for with the prompt. A woman making a heart gesture with her hands. And if you look closely, the character's identity in the video matches perfectly with the input image we provided. BindWeave is clearly doing its job really well, just like what we saw earlier in those benchmark examples. So with this, our basic workflow is working perfectly. From now on, you can generate videos of pretty much any character you want using this setup, and the best part is it's completely free. As you can see here, this particular workflow is designed for a single target character while keeping the background unchanged. Since this video is already getting quite long, I'll save the workflows for multi-character setups and object interactions like what you saw in the intro for the next video. If you want those tutorials to come out sooner, drop a comment below and let me know. In the meantime, make sure you watch this video carefully and get this workflow set up correctly. Once you do, you're going to get some seriously fun and impressive results. And that's how you build a basic BindWeave workflow, a solution that lets you control any character you want in videos generated with one video. I really recommend watching the video from start to finish so you can catch all the small tricks and optimization tips I slipped in along the way. If you found this tutorial useful, don't forget to hit like and share the video so more people can discover this channel and these AI tools. Thanks for watching. I'll see you in the next one.